What's up, everyone? In the first of our physics lectures, we are going to be talking about 2D kinematics. And to start right off, this has to do with acceleration, A, velocity, V, and displacement, which is X. And now, we just start out, displacement we know is just the distance that a particle or object has traveled, measured in meters, and velocity is the rate at which displacement is changing, or dx dt, the derivative of displacement, which is measured in meters per second. It's the speed of something. And lastly, acceleration, which is the rate at which an object changes velocity. It's measured in meters per second squared, and just measuring like how fast an object is increasing or decreasing its velocity. And so by these rules, we know that v is the derivative of x, a is the derivative of v, and vice versa. V is the integral of a, and x is the integral of v. So to start out with our equations, we assume a constant velocity throughout our physics class, meaning that the acceleration is just a, and it's a constant, it doesn't change, it's independent of time. And now, to get our first equation for velocity, we need to integrate the acceleration because we know that a is the derivative of v, so therefore integrating a with respect to time, dt, is going to give us velocity. And so if we integrate this, a is just a constant, we just get v equals a t plus c. Now, c is a constant, we don't know, it's the starting point, but we like to call it v naught, which basically just means the starting speed of the object. So we know that v equals at plus v naught. So now to get our displacement equation, x, we know that it's the integral of velocity, which means we're taking the integral of at plus v naught, and with respect to time. And this will get us, power rule becomes 1/2 at squared plus v naught, we just add a t, and then plus c. And same thing with velocity, we like to call our c x naught, meaning the starting place for x. And then lastly, if we subtract x initial, that's the starting point, or x minus x initial, which is, this is x final, that's x initial, sorry. We get x final minus x initial equals delta x, which is the change in x, change in displacement, equals 1/2 at squared plus v naught t, which these are our three equations, and a is just constant. And so with these three equations, with all these problems, all we need to do is just plug in different values of a, different values of v naught, different values of t, and what is given, and we can just solve these equations for the unknown. All right, question number 1. This question asks about a plane, which it gives us the acceleration a equals beta times t squared, and they give us beta as 1/90 meters per second to the fourth, and the question asks to find the plane's final velocity after 30 seconds. So just quickly substituting for beta, we get acceleration equals 1/90 t squared. That's the formula for acceleration. And now we know that acceleration is the first derivative of velocity. So to go the opposite way to get velocity, we need to integrate acceleration in order to get the formula for velocity. So integrating acceleration, which would be equal to velocity, equals the integral of 1/90 t squared dt, which equals, by the power rule, we need to divide by 3 because we're going to get a third power to get 1/270 times t to the third power equals velocity. And this works because if we take the derivative, the 3 goes to here, makes it 1/90, and that becomes a 2, and that's our correct formula for acceleration. So now to find the final velocity after 30 seconds, we would need to integrate this from 0 to 30. And we know it's a polynomial, so plugging in 0 will just give us nothing. So we just need to find, if you plug in 30 to t, what we will get, and that will be 30 cubed over 270. And now to factor this, we have 3 cubed times 10 cubed on the top over 270 is 27 times 10, which is 3 cubed times 10. 3 cubes cancel out. We have a 10 canceled out, and the answer is 10 squared. And of course, in velocity, the unit is meters per second, which gives us the answer of C.